So in this problem, you're given three circles, and they're not drawn to scale. They could all be the same size at the beginning. You don't know, right? And the way they're drawn doesn't give anything in a way but the indication of the size of these circles. All we know is one circle is called A, the other is called B, and the other is called C. And furthermore, you're given these three lines drawn between the centers of the circles, and you're told about the total length of each of those lines. So here are the things you're told. First of all, you're told that the length of AB. So this length right here, if I draw a line from the center of A to B, that length right there is equal to 7. And you're told that the length of B to C is a little bit longer, right? It's 10. So now you know, oh, well, something about C must be longer than A because when I add B and C, I get more than A and B. And lastly, you're told that when you add A and C, you get 11. So, or when you have the length AC, you get 11. So that is the way the problem's set up. And then I think it's nice to begin to unravel this problem by getting away from the circles entirely and just kind of writing these lines out. Like we have AB, right? We have BC, and we have AC, right? And again, not to scale, just a representation of how you might start thinking about this problem, right? So if we go from A to B, we get 7. We go from B to C, we get 10. And we go from A to C, we get 11. And then we start thinking, oh, well, you know, somewhere in each of these lines are the breaking points of each circle, right? So that means that we're adding the radii from each circle to get these numbers. So then I started to think, well, if this is really like saying the radius of A plus the radius of B equals 7, and then we have here the radius of B plus the radius of C is 10, and lastly we have the radius of A plus the radius of C is 11. And now what we have is a system of equations that we can solve quite manageably, right? So the idea is to turn all this information into a system. So our system of equations, I'll write them all next to each other. A plus B equals C, B plus C equals 10, and lastly A plus C equals 11. This is like any linear or nonlinear system. Your goal is to begin to cancel variables out. And really, I can kind of pair this up however I want to here. I'm going to reduce by combining A plus B to A plus C. So A plus B equals 7. And I notice here we also have the variable A, right? A plus C equals 11. So what I like to think about is multiplying my equation A plus C here by a negative value. So everything in that equation. And what I get is negative A minus C equals negative 11. And if I add that to my original equation, A plus B equals 7, what's going to happen? Well, I pair these two up because they both have the variable A, so I can just add or subtract opposites. And if one had 2A and the other had just A, I could double and get the opposites. The goal is to set these equations up so that when you add them, you eliminate a variable, right? So here A plus negative A, it's eliminated. B plus negative C is B minus C. And then 7 minus 11 is negative 4. So now, right, now I have a new equation. B minus C equals negative 4. And now I'm in a really great position because I have two matching variables, B and C, to this middle equation here. And now I can easily solve. We have our original equation, B plus C equals 10. Now we have B minus C equals negative 4. And if I add these two equations together and add them almost just like numbers, negative 4 plus 10, right, 6. C minus C cancels out, and B plus B is 2B. So 2B equals 6, divide both sides by 2. All right, and then we know that B equals 3. So we've got one radius right there. We're told in the beginning A plus B equals 7. And I know we could just see this almost, but just plug the value in. B is 3. So A plus 3 is 7. Solve for A. Subtract 3 on both sides, and A equals 4. And lastly, we have C, so let's solve that one last. We have A plus C equals 11. A is 4, so 4 plus C equals 11. Subtract 4 from both sides, and C equals 7. And we can see this is true if we go back to our diagram, right? This is 4, this is 3, right? And this is 7. This is 3, this is 4. So 4 and 3 is 7, AB is 7. 3 and 7 is 10, so BC is 10. And 4 and 7 is 11, so AC is 11. All right, hope